Let's take a look at this example. Let's check what we have to find first. So I have find. We do not have R total. We do not have R3. We do not have voltage source. We do not have I source, other words I total. Okay, and this is basically it. So, first of all, always look for the component which has two pieces of information. Okay, so R1 is the resistor which has two pieces of information, because R1 has given the resistance and current. So having the resistance and current, I can find the voltage across this resistor. Keep in mind that this is parallel circuit. In parallel circuit, the voltages are the same. Okay, so I can say that voltage source is equal to VR1, this is also equal to VR2, this is also equal to VR3. And how I'm going to find this value? Simply multiply R1 times I1. R1 times I1, because voltage is equal resistance times current, or current times resistance. So my voltage VR1 is going to be equal, R1 is 6 kilo ohms times I1, which is equal to 2 milliamps. So this is equal 6 exponent 3 times 2 exponent 3 negative, okay, equals 12 volts. Okay, I do this on the calculator. Even the calculation is very simple. Just make sure that all of you are going to be familiar with the engineering notation, because many students fail the test because they do not use exponents. Okay, so we found the voltage, and we have voltage across each resistor, including voltage source. Next, I can find current which goes through resistor R2, okay? Or I can find the resistance R3. Let's see what is better for us to find. I believe it's better for us to find is R3. Why? Let me show you. We have formula for power which says P3 is equal VR3 to the second power over R3. Now, in order to find the resistance from this formula, I'm supposed to multiply both sides of my formula by the denominator of my fraction. I have to multiply by R3. R3 and R3 will cancel out, and I have R3 times P3 is equal VR3 to the second power. Okay, I'm looking for the resistance, so I have to divide both sides of my formula by P3. So P3 and P3 will cancel out. Okay, and I'm going to have R3 is equal VR3 to the second power over P3. Okay, so right now I'm going to plug in the values. So VR3 is equal 12 volts. I have to raise this to the second power over P3, which is equal 12 milliwatts. This is equal 12 to the second power divided by 12 exponent 3 negative. This is equal 12 kilo ohms. Okay, so we found so far R3, we found voltage source. Next we're supposed to find the total resistance. Because we found already R3 and we have given R1 and R2, I'm going to find R total. R total is equal 1 divided by, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3. This is equal 1 divided by, open parenthesis, 1 over 6 kilo ohms plus 1 over 9 kilo ohms plus 1 over 12 kilo ohms. Okay, this is equal. I have 1 divided by, open parenthesis, 1 divided by 6 exponent 3 plus 1 divided by 9 exponent 3 plus 1 divided by 12 exponent 3. This is equal 2.76 kilo ohms. Okay, so this is the total resistance of my circuit. Please notice that the total resistance, okay, 2.76 kilo ohms, is lower than the lowest resistance in this circuit. The lowest resistance in this circuit is 6 kilo ohms. So if we got R total less than the lowest resistance in this circuit, it means that we are doing so far everything correctly. Next, we're supposed to find I source. By the way, let me just remind you that the circuit which we have above, you can replace by the simple circuit which contains just voltage source and resistance RT. Okay, so this is my voltage source and this is my RT. Okay, so this circuit is equivalent to the one which we have above. So if you want to find the total current, I total, or we can say I source, this is the same thing, is equal voltage source over R total. Okay, so this is equal voltage source 12 volts over R total, 2.76 kilo ohms. Now I'm going to use the calculator, and I have 12 divided by 2.76 exponent 3. This is equal 4.34 milliamps. Okay, so we found R total, we found R3, voltage source, I source. So we can say that the problem is solved.